All right, so we're going to talk about a couple of different modes that you can graph in. If you've ever gone to your graphing calculator and hit the mode button, we have always worked in the mode that's labeled function on the far left. But if you've noticed, there's also a PAR and a POL and an SEQ. So the PAR mode is called parametric mode, and I'm going to kind of teach you what that's about and the power of it. Parametric equations is basically taking a function and breaking it into two separate equations, like a horizontal component and a vertical component, and introducing a variable of time. And that's what we call the parameter. So basically, what it is it's looking at a function over time, is the way I like to think about it. And that t is what your parameter is, and that's why they call them parametric equations. And what is a parameter, right? Well, it's just like a bound, right? Why can't I spell parameter? That's embarrassing. Parameter. I can't be right. Sure, it's right. Okay, so how this is going to work is basically like, instead of me giving you f of x is equal to, you know, blah, 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 okay, instead I'm going to give you an x equation with respect to time and a y equation with respect to time. And these are what's happening simultaneously to tell your position what to do. So as an example, it could be like 2t minus 3, and maybe this is like a t squared plus 1. Okay. So what this is saying is that let's say that we wanted our time interval to be between 0 and like 4 seconds, okay? Then what we would do is we would look at what's actually happening here at 0 seconds, 1, 2, 3, and 4 seconds, and you just have to find your position at those different times. Well, how do you find your position? You just plug these fellas in to each equation. So it's pretty dang easy. So if I want 0, I'm going to plug a 0 into both this one and this one, and I'm going to get my position at 0. Let me make a little table out of this. All right, so if I plug in a 0 to this is some quick mental math here. We're just going to get a -3, and when I plug in a 0 for the y, I'm going to get a 1. So that is my first position point. So when I go to graph it, I'm at -3, +1, and that is going to be my point when the time is 0. So notice there's no axis for time. It's just happening in the background. This is still your x-axis. This is still your y-axis. Okay, so now let's try 1, right? If I plug in a 1, 2 times 1 minus 3 is -1. If I plug in a 1 there, I get a 2. So at 1 second, I'm at the position point -1, +2. And then if I plug in a 2, I'm at the position 1, 5. And notice there's starting to be a curve to this. So what I like to do is when I sketch my parametric, I like to show direction. So I'm going to put little arrows on this so that I know that as time goes by, this is the way my graph is traveling. Now, when I plug in a 3 and a 4, these data points are actually going to be way up here, and I'm going to be out of room. So shame on me for not thinking ahead. But you know what we can do to fix that? We're just going to change the problem. Let's pretend it just said 0 to 2. Voila, problem fixed, okay? So I'm not even going to look at those. So basically, here is my curve. Now, if you're wondering or if you're curious how that sort of makes sense in the world that we normally live in, this function mode, there is definitely a way to go from x and y back into function mode, or what's called rectangular mode or Cartesian mode. All of those are synonymous. And the way that you do that is you eliminate the parameter, is what people say in the math world. And if you're told to eliminate the parameter, it basically just means like get rid of t, get rid of time, and go back to a normal f of x equation. And doing it is actually really easier than you probably think it's going to be. All that we have to do is a little substitution problem. So I'm going to scroll down, hopefully, so you can see. All right, so what's going to happen here is I'm going to take these equations that I just have, and I'm going to not think of them as functions, but just as a normal x equals 2t minus 3 and a normal y equals t squared plus 1. And my goal is to get rid of t and write it as an f of x equals or a y equals. So what I like to do is I like to go to my x equation first, and I like to isolate the t. And after I do that, I then substitute it into the other equation, and I'm done. So how do we isolate t? Well, on this one, we're going to add the 3 to the other side. And then to get t by itself, we're just going to divide both sides by 2, right? Okay, so t is now equal to x plus 3 over 2. Now I go to my y equation, and if t is equal to all that, then I can sub it in to its spot. Do a little substitution, just like it was a system of equations or something. And this is my equation. So really and truly, what you're seeing above is part of a parabola, right? And how do I know it's a parabola? Well, I have an x squared here. This is a parabolic term, so or equation, like a quadratic equation. So we're seeing part of a parabola, and we could graph this whole thing, and guess what? It would in fact land on top of this. It's just that we wouldn't see the time happening in the background. So that's kind of how this works. Now, why do I like parametric? Well, I think they're super useful to get to do cool stuff. For instance, conics, baby. We just had a conics unit, and we couldn't graph a dang thing on the calculator because, well, you just can't graph a function on a calculator, or so you thought. If you can take your conics and you can actually write them in parametric mode, you can, in fact, graph them in the calculator and check your answer and so on and so forth. And what I would ask you to do is I'm going to write it kind of a parrot function out so that you can take a look at it, but please do this in your calculator. Let's take something in standard form, like x plus 1 squared over 9 plus y minus 3 squared over 16 equals 1. So the first thing is, hopefully we all know this is the equation of an ellipse. We know where the center is. The center is -1, 3. We also know that our radius for the x-axis is really a 3. And we know that our radius for the y-axis is really a 4 because we're taking the square root of those. All of that is stuff that you know how to do. Now, in parametric mode, okay, if you want your x and your y equations, here's how this actually works out. You take your radius for your x and you multiply it by the sine or cosine, it actually doesn't matter, sine or cosine, of t. And then you've got your plus h behind it. So if there was a shift to the left or right, it's going to be very literal behind there. And for your y, it's going to be the y radius times the cosine or sine. Just make sure you have one of each, okay? It doesn't matter where they go, but you need to have one cosine and one sine. And then you've got your k. So in other words, I could take this ellipse that I already know, or I should already know kind of what it looks like. If I want to see it on the calculator, I'm just going to type everything in the right spot there, and it's going to be 3 cosine of t. And my h is really a -1, right? Here's my hk. My center is my h and my k. These values over here are your h and k. And my y equation is going to be 4 sine t. And then what was that a positive 3? Plus 3. So what I can do is go to my calculator. And I wish I had an online calculator to do this with you, but I don't because I'm not cool like that. And I don't have money for that software. So shut up. We're going to go to our calculator that's in our hands right now. And we're going to hit mode. Then we're going to go to PAR mode for parametric, and you're going to select that, so hit enter. Then you're going to go to y equals, and notice when you get to the y equals screen, y'all, you're going to see this. It's miraculous. And once you see this, you're just typing this stuff in. Now, don't overthink the t. If you're like, where's the t? How do I type in the t? Okay, guess what? That little button that you always use for x, look closely at that little button. It's got an X on it, it's got a T on it, it's got a theta, and it's got something else, an N maybe. If you hit that same button, it automatically knows to turn it into a T for you. But anyways, you could type this all in, you can hit graph, and guess what? You're gonna see your cute, adorable little ellipse. Isn't that cool? So this works for both ellipses and circles, right? So the only difference on a circle is that these two numbers would be the same. Hopefully we all know that. Those would be the same if it was a circle. But it would work the same cosine sine, and then your center over here would be dictated by your h and your k. All right, cool. So how do I make a hyperbola? Because a hyperbola is a little different, right? Okay, so for a hyperbola, the parent function would work out sort of like this. Okay, we still have our x and our y. So this is a hyperbola, hyperbola, okay? On this one, you don't use cosine and sine. You actually use two other trig functions. You're going to use your Rx, Ry. You're going to use secant and tangent. And here's the kicker. Where you put secant and tangent is going to dictate if it is a vertical ellipse or a horizontal ellipse. Now, the way that I'm writing it right here, with secant going with x, this is going to be a side-to-side hyperbola. So if x is in the lead of your equation, remember if x is in the front and then it's a minus and then a y, you want the secant to go with x. If you were to flip-flop those and you were to put your tangent first, so it would be like Rx tangent t plus h, and then the Ry secant t plus k, that's when you're going to get a vertical hyperbola, because secant dictates the shape or the orientation. Okay, and that's pretty much how that works. So feel free to try it, check it out. And remember, if you're trying to type in secant, there is no secant button. So you're going to actually have to type it in as sort of like your Rx divided by the cosine. Because remember, secant is equal to 1 over cosine. So when you're typing it in, there's a little tip for you. That's how you're going to have to type it in. So that's how parametric works. You can graph in parametric. You can eliminate the parameter. You can also do your conics this way. I'm not going to show you in the video, but you can also do parabolas. And it's actually pretty basic. I want you to play around with that, and we can actually talk about that later. Next time I see you, if you can't figure out how to do a parabola, we will chat. But hopefully that helps out with parametric mode and all the coolness that can happen there.